Hello students, in this lecture we will be seeing about priority CPU scheduling, both preemptive and non-preemptive types. Okay, usually it will be a non-preemptive one, rarely it is preemptive. Here each process is assigned a priority and the process with the highest priority will be executed first and so on. Process with same priority will be executed on first come first serve basis. Okay, now let's see the non-preemptive type first, then we will focus on preemptive one. Okay, non-preemptive. So here the process process has been given arrival time, execution time, and the priority is given here. Priority highest number will be the highest priority. So this process will be executed first, then this process, then this process. Okay, so let's it's a non-preemptive type. So we will start from here. P3, then next higher priority is P1, then P0, then P2, P0, P2. Okay, so we will start. Let's start from 0. Then see P3, its execution time is 6. So till 6 it will be occupying the resource. Then comes P1. It has 3 execution time. So 6 plus 3, 9. So from 6 till 9, 7, 8, 9, these 3 things, this P1 will be utilizing in this time. Then priority process with the same priority will be executed on first come first served basis. So P0, last one P2. So P0 will be executing, its execution time is 5. So already 9 plus 5, 14. Then the next thing is 8. So 14 plus 8, 22. Then we need to find the arrival time and turnaround time. As you know earlier, if you see my previous lectures, you will be knowing how you can calculate the turnaround time and the average waiting time. Okay, the turnaround time will be calculated by using the formula C minus A, that is completion time minus arrival time, and waiting time will be calculated from turnaround time minus burst time, that is execution time. Okay, depending upon this formula, we can be able to find the average waiting time. Now, well, let's see the preemptive type of the priority scheduling. So, we considering 5 process P1, P2, P3, P4 and P5. The arrival time is given. The burst time is also given. Priority is also given. Okay. Now we need to arrange the process in Gantt chart. Okay. So the highest number will be the highest priority. So here 2 has highest priority. And if same number comes, process with the same priority are executed on first come first served basis. So we have to take this one first, then we have to take this. Okay, so we need to start from this point. But in preemptive there is a concept, that is here the high priority process is P4. Okay, but it arrives at 3 only. The arrival time is 3 here. Okay. So, until 3, we can allow others. So, till 3, we can allow other process to execute. So, from starting, we can consider P1, its arrival time is 0. So, each thing will be getting 1 point, that is in preemptive. First, for one time, the very first process is executed. One time. Okay. So, only one time, till 1, the first process will be executed. So, the burst time pending extra remaining thing will be 3. Okay. Then next one, from 1 to 2, P2 will be executed. Then 2 to 3, P3 will be executed once. So we are striking it off. It becomes 2, striking it, and it is becoming 0. This P3 is over. Okay. Now only the highest priority process P4 is coming. It has to be executed within 3. So already it's from 3 till 5, that is 3 plus 5 8, it will be occupying the resource. So the entire thing will be over. Next higher priority is this thing P5. It has 2 burst time, so 8 to 10 it will be executing, and this process will be also over. Next, already this is over, so only these 2 are pending. Okay. Now see who is having the highest priority. P2 is having highest priority when compared with P1 and P2. Okay. So this thing will be executed, and finally only P1. So process P2 is having 2. Okay. Already 1 is over, and the remaining 2 will be over here. And finally P1, already 1 is over. The remaining 3 will be over here. So it will be closing at 15. The other things are similar to other CPU scheduling algorithms. So we can calculate the turnaround time and the waiting time similar to that. That is, turnaround time equal to T equal to completion time minus arrival time. Then waiting time equal to turnaround time minus burst time. Okay. The others are similar. So please note the concept here. Okay. And I will tell again once more. This preemptive, this is the preemptive, the same example. Okay. So first this process is coming. Okay. Until P4 is having the highest priority. So until 3, we can execute these 3. Okay. So this will be executed once, this will be executed once, and this will be executed once, and it is being getting over. So we are striking it off. Okay. Now only this P4 is coming. Okay. Now only at arrival time 3 it's coming. Okay. Then after it gets the resources, it will use fully. So till 5, that is 3 plus 5, 8. Until 8 it will be executing, and it will be over. Okay. So it will be 0. Then the next highest priority is P5. So from 8 to 10 it will be executing, and it will be also getting over. Then only the remaining 2 cases exist. Among these, this is the highest priority. So from 10 to 12 this thing will be executing, and it will be over. Then finally these 3 will be getting over from 13 to 15. Okay. So now I hope you can understand better. Okay. We can see the remaining CPU scheduling algorithms in the next lecture. Thank you.